Hey everybody, how's it going? Today we're going to take a look at 20A, which is cumulative frequency graphs. We're going to look at how to construct a cumulative frequency graph to represent data and how to find percentiles and apply them to a set of data. Cumulative frequency distribution table is a table that shows a number of proportions of scores that lie above or below a particular value. It gives progressive total. Cumulative frequency graph, the graph that represents the data from the table, provides a convenient way to find percentiles. It is plotted at the right end of a boundary of an interval. This is key. It's the right-hand boundary of the interval. We'll look at that in a little bit when we create one. Now, percentiles, the score which a certain percentage of data lies at or above. Lower quartile is a 25th percentile. Median, which is Q2, is a 50th percentile. Upper quartile, Q3, is a 75th percentile. Now here we have a cumulative frequency graph. There are 240 participants, if you will, in this particular graph. Here's your quartile 1, 2, and 3, and then your percentages. Now, quartile 1, I take 25% of 240, which is 60. So what I can do, here's quartile 1, here's 60. From here to here, that's 25% of your data, but this represents the 25th percentile, as you see over on the side. Quartile 2 is 50% of the data. So 50% times 240 is 120. So if I were to connect these two together, this represents a 50th percentile. So here's 25%, here's the second 25%. Now remember, this is 25th percentile, and this is a 50th percentile. Quartile 3 represents 75% of the data. So 75% of 240 is 180. So this is your 75th percentile. Now anything from here to here is the upper 25% of the data, or upper 25%, or excuse me, upper 25th percentile of your data. Now the data shows the results of women's marathon at the 2008 Olympics for all competitors who finished the race. So who finished it. So 8 competitors finished in 2 hours and 26 minutes to 2 hours and 28 minutes. 3 competitors finished in 2 hours and 28 minutes and 2 hours and 30 minutes. Notice the first entry is a less than equal to symbol, where the second one is a less than symbol, because what you want is a lower time when you're running a marathon. Now when you plot these, we are going to plot these using this number right here, these numbers right here. Now we're going to go ahead and figure out the cumulative frequency. What we do is we add up all the frequencies within the time interval. So my first frequency is 8, because that's the only thing I add together. My second frequency, what I can do is I add 8 to 3 to get 11. So 8 plus 3 is 11. Then I add 11 to 9 to get 20. And what we do is we continue this trend until we finish adding up these data values. So this is 43, 50, 55, 63, and 69. So 69 people, women, finished this race in 2008 at the Summer Olympics. The next thing I'm going to do is I'm going to represent this data in this frequency table. What I've done is I've gone ahead and taken liberty to fill in the legends and also the scales on both sides. Start here at 0, and then in 2 hours and 28 minutes, 8 people finish. So here's my 2 hours and 28 minutes. What I do is I'm just going to put a little dot that's approximately 8, represents 8. Numbers upper side represent the number of people that finished. Down the bottom, that's the time. The next interval that I'm going to put in is 11. So 2 hours and 30 minutes, 11 people finished, so I put a dot right there that represents 11. Continuing this, 20 people finish at 2 hours and 32 minutes. 31 people finish at 2:34. 43 finished at 2:36. Here's 2:36, 2 hours and 36 minutes, and I want 43. 50 people and finished in 2:38. 55 and 240. So here's 240. $63 at 248. And finally, 69 finished in 256. What you want to do is use a smooth curve as possible to connect your dots. And there is your cumulative frequency graph. Now estimate the median. So what we do here is we take 50% of 69 equals 34.5. Now, what we can do from here is we can go to our graph at 34.5. Here's 35, and come on down. If we look at the time, here's 34, come on down. Look at your time here, and that time is going to represent approximately 2 hours and 35 minutes. Number of competitors who finished the race in less than 2 hours and 35 minutes. That is approximately 35. Percent of competitors took more than 2 hours and 35 minutes to finish. What I do is I find 239 on my graph. Here's 238. Here's 2 hours and 40 minutes. So I go up to my graph, and that is approximately right here, and that is about 53 people. So then you can take 69 minus 53. That equals 16. Divide 16 by 69 because that's the number of people that competed or finished the race. And that equals 0.2319, or 23.19% of the people took more than 2 hours and 39 minutes to finish. Now the last thing is the time taken by a competitor who finished in the top 20% of the runners competing in the marathon. So I'm going to take 0.2 times 69. That equals about 13.8. We're going to round that up to 14. Now I find 14 on my graph. Here's 15, here's 14. I come on over, and it hits the graph right about 2 hours and 31 minutes. That's it, folks. Have a good day. Take a look at the note guides. Complete the notes.